Hi, this is Mark Bina, CEO and Principal Analyst at SmartTech Research. I'm here at OktoberTech, Infineon's big event that they do every year in Mountain View. I'm excited to be here. And I'm here with a couple of interesting guys that I'd love to get a kind of a synchronization discussion on quantum computing. I'm here with Richard
Kuncic?
Yes. With Infineon and Russell Stutz with Quantinuum. Yes, thank you very much. You meet a lot of new people when you're out here in the field. Let's talk about, we're going to get into the whole quantum computing piece. But first and foremost, why is quantum computing as a category so important to Infineon?
It's becoming increasingly important because we are really addressing the whole topic of computation, from a power flow perspective already, right? So we power AI and we take care of the complete power flow in a data center, from grid to core. And as we see, with all these gigawatts of computational power deployed, there is nearly an exponential growth of power demand. So we are of the opinion that this cannot just continue like that. We need to find smarter ways of computation.
Yes.
And here we believe that quantum computing can be or will be one of those solutions, because there are simply some problems to solve, some computational problems to solve that can be addressed in a much more efficient
manner
and better way compared to this classical compute that we do.
And Russell, that's my question for you. We're going to talk about, well, first of all, what does your company do?
So we're focused on a full stack quantum computing company. We provide hardware, but also software solutions, full software stack all the way up to applications for our customers. So again, trying to address problems that just can't be solved with classical means, and which scale much better on quantum computers.
And that's the operative thing, because you said something, Richard, that's very interesting, is that quantum computing is it's not just an evolution, it really is a complete revolution in the way that typically computing is done. And as you said, and Russell, you hinted at this as well, believe it or not, everybody, there are problems out there that are so complex to solve that conventional computing can't do it in an efficient manner.
Or cannot do it at all.
At all, exactly. So
exactly.
let's talk a little bit about that.
Those are these kind of mathematically hard problems where you have a slightly increased set of input parameters would increasingly make it more difficult to compute the challenge. And this is where we say it makes sense for us to invest now early on.
Yes.
In order to enable this, what we believe will be the most transformational technology, in that field of computing for the next decade.
Now, Russell, here's a question for you, the $64,000 question. Why is the partnership with Infineon so important?
So in order to scale these quantum computers, that goes for trapped ions, but also basically all other modalities. To truly scale, you need to use microfabrication and nanofabrication techniques. And Infineon brings just so much expertise and know-how and tooling to go build the machines. And they've been a great partner working hand in hand with our engineering and science teams to continue to work on how do we scale this to get to what we call fault-tolerant quantum computing, where it needs hundreds of thousands or even millions of qubits in order to really solve the world's hardest computational problems.
Right. And I will say that, because I've been working with Infineon and covering Infineon for years, what Infineon's really good at is getting cost out of solutions. And right now, quantum computing it's coming down in cost, but it's still a fairly expensive implementation, but it will come down. And scale is going to be behind driving the cost coming down. Would you agree with that?
Yeah, absolutely. And in this case, it's this combination of this exceptional technology on a system level that Quantinuum brings in, and basically our engineering and manufacturing capabilities in order to really then ensure this high quality components that you need in order to enable these high fidelities then in the qubits. And the better we do our part, basically the ion traps, the less error correction is then needed on top of it. So it's really a good combination of science turned into real hardware that is already kind of performing very well, and our engineering capabilities and manufacturing capabilities in silicon technologies.
Great. Well, guys, thank you for your time. Enjoy the rest of the event. This is Mark Bina with Smart Tech Research signing off. Hi, this is Mark Bina with Smart Tech Research coming to you once again from OktoberTech in beautiful Mountain View, California. I'm here with an old friend, Sam Jiha, with Infineon. And I have a feeling the word AI is going to creep into this conversation. But Sam, tell the audience what you do at Infineon.
Well, I run a couple of businesses. One of them include the microcontroller, the MCUs, and the other one is Wi-Fi and Bluetooth businesses. And I'm super excited to be here today. We're making a major launch for our Edge AI product, MCU product.
Now, OktoberTech is, I mean, you really have to be here to experience it. It's such a potpourri of really great demos. A lot of the technology that's shown here, services and products that you may actually have in your house, believe it or not. Some of these are future technologies that will be coming down the road. But, we're now seeing this enormous influx of AI capability, AI in the edge. You coined that phrase.
Yeah.
Why is AI in the edge so important to Infineon?
It's a great question. I want to even start, why is it important to me first?
Sure.
And why is it important to Infineon? So a couple of months ago, I turned 60. And I'd say...
That shocks me.
And I say, starting with age, 60 is the new 30. So how do I stay young? And how does Edge AI actually help me feel, have a better life? And Health-wise, for sure. And if you look at how the world is evolving, a few years ago, they used to have the trackers for steps. Say, okay, I walk 10,000 steps a day. With Edge AI, you're able to do a lot more than that. You're gonna say, okay, are you walking just as healthy? It starts looking at your historical data and tracks, okay, are you getting tired? Are you getting tired earlier? It can also check your pulse, your heart rate, your pulses, and says, okay, well, maybe you should be taking a break. So this predictive behavior is kind of due to the advancements in algorithms by taking that old data, analyzing it, and starting to predict when you should be taking a break. Or let's say you're in a place where there's no Wi-Fi, and like sometimes Wi-Fi is pretty spotty, even in Silicon Valley. So it actually can analyze the data right there at the edge, at the device, without having to go to the internet or to the cloud and analyze the data and come back. So that's why it's super important, and this is what we're excited about.
Well, that phrase "on the edge" is really important because people have smartphones that have AI apps. There's AI in the cloud. I go ad nauseum in terms of how AI is in our life, but the on the edge piece is particularly important because you just highlight something that's crucial.
Yeah.
Maybe one day, 5-10 years from now, we'll have ubiquitous connectivity everywhere, but there are places, even in the United States, that sometimes not AI, but AI connectivity is hard to get to.
Yeah.
And a lot of this technology now has the ability to execute AI usage models just being on the edge without necessarily a connection.
Well, there are at least 3 big advantages for having that ability to be at the edge. Number one, let's say you're driving cars, right? And your sensor is intelligent. Your sensor cannot send signals to the cloud to analyze data and say, okay, this next car is close to me, what do I do? You need intelligence right there. You need the sensor to be smart and intelligent. So that's one of the applications where it's got to be right there at the edge.
Yes.
Another one is, like I said, the no Wi-Fi. I mean, there's many places where you can't depend on Wi-Fi. That by itself could have other advantages. Let's say you're building a product and you don't really need to add specifically Wi-Fi capability. You could be saving on cost and saying, okay, I just need an intelligent MCU. I got all the data loaded in it. And the third huge advantage there is security. Do you really want your health data to be
up
going
in the cloud.
To the cloud, or you want it to be private for you? And the advantage of the edge is you have it right there on the device only and nowhere else. So that privacy is becoming a very big topic and super important. Similarly, I mean, facial recognition, right? You don't want your face to be posted all over the cloud and people can have access to it and and fake it. So many advantages where edge AI is helping you, just be a little bit better, have your products be superior.
Right.
Yeah.
Now, Infineon at the end of the day is a design wins company. You know kind of what's coming down the pike a year from now. Are there any categories broadly, and I know you can't mention specific companies, but are there any broad categories of products that, hey, you know what? We see a trend, that there's an area that this is catching a lot of momentum. Can you give me some color on that?
Well, I mean, the trends continue for us to be, I call it incremental improvements, right? We do want to make the world's best sensors. We do want to make the world's best power products. We want to make, so it's just, I call it a lot of incremental improvements. So one category, I call it just making the products more robust. So, for example, with the or when let's say it's getting used a lot more frequently at days versus other days, you want to send a signal. You want to study the vibration data and predictively send a signal to say, hey, maybe it's time to send a maintenance guy. Not based on, okay, it's been 2 years and I send the guy, but maybe in a year,
No, my favorite movie is 2001: A Space Odyssey, and that the premise of that movie is like Hal, who was a bad guy, the bad computer. He has the astronauts go outside because he tells the astronauts that an antenna is going to fail in 2 weeks. It's not failing now.
Yeah, exactly.
But it's going to fail now. But that's a big deal, especially in an EV or even a conventional car where you want, because it lowers cost. If you can replace a part before it fails, first of all, it's a better experience. Number one, you reduce the cost of maintaining that product, but no, the predictive piece is big.
Yeah, and similarly, the next thing beyond that is, let's say your cameras are going to get smarter, your sensing is going to get smarter. You want to walk into your home and you want even the TV and the air conditioning to recognize you and say, okay, I guess Mark really likes the room at 72 degrees, but Sam likes it at 68 degrees. And based on facial recognition, it tells, okay, let me make the room be comfortable. Or say, it's really Mark that went into the room, not like some robber or not like his dog, or, so those will continue to evolve over the next 2-3 years. And we really want to be there with, with our Edge AI products to help in that area and help enable it.
Just in a couple of minutes, any crystal ball stuff? If you could take a look, hey, kind of here's what we might expect 5 years from now, 10 years from now. 10 years probably too.
These days, 5 years is way too far ahead. But what I see is more and more AI will be used to, I'd say, slowly make things better, make life faster, even for designers to design products faster, for products to be used better. I'm more about incremental improvements as opposed to the big revolutionary. And I see a lot of, just incremental improvements in many areas because of AI, and in some cases because of Edge AI, where AI is too expensive.
Right.
I also see, when you use Edge AI, you're using a lot less power. So if you're thinking from a power efficiency or, wearable devices or battery power devices, you just need that, that intelligence there. So all your cameras will be a lot smarter. All the products you have will be better. So.
Well, a couple of things. First of all, you don't look 60. Let's state that for the record.
It's a new 30, right? Yeah.
It's a new 30.
Yeah.
And I always, it's interesting how, you've been with Infineon a long time, but they always take guys, they put them in businesses that they know have lots and lots of potential, and they got the right guy in that, managing that area, and I appreciate your time.
Thank you very much. I
Thank you very
appreciate
much.
it. Always great to see you and catching up.
Mark Vino with SmartTech Research. Thank you again.
Okay, Mark, so, one of the examples that we're training our Edge AI to do is facial recognition. As you know, we really have, I would say, pretty much perfected voice recognition, but I'm going to show you a demo here where our facial recognition is already becoming a feature where you can do it, I would say, a lot more cheap than using an MPU. And that's how we're thinking about it from a system cost reduction standpoint. So this demo right here, if I just stand there, I just already did my face, and I'm user one, but if I got somebody else's face that it doesn't recognize, Okay, you can see he's unknown. So maybe we can come in and get your face in here, and let's
Sure.
get you to become user too, maybe.
Okay.
So go ahead.
So you'll have to move out of the
All right. Yeah. Oh yeah. Let me move out of the way.
Unknown.
Now you have to do head poses until each box turns green.
Down.
You hold it for, that's good, then up.
Roll pose.
Yep. See the red go to the higher box. There you go. You hold it for a second. Yep. And then you have to do left and right. That's good. You go too far. That's good. Yeah. On the other side.
All right. So
Wow.
what are you now? Are you user 2?
I'm user 2.
So let me see. User 1 and user 2 are together. And if we get a third unknown, then it cannot recognize your face.
That's pretty cool.
Yeah.
It's very cool.
See, so this is part of what we're trying to enable here for smart home application.
And this is all real time.
Of course.
Yeah, this is
Okay. Okay, user 2. So,
Nice to meet you, user 1.
Thank
to
you.
know.
All
Thanks,
right.
man.
See you. All right.
Hi, this is Mark Bina with SmartTech Research with another report from good old Infineon's OktoberTech. I'm here with a good friend, Adam White, whose title is Big Shot of the Robotics Group. That's not exactly the title. But Adam, this has really been a great event. I'm with a special guest here. And by the way, anybody who sees this on FaceTime, this is not my girlfriend. Be very careful about that. But Adam, let's talk about what you do at Infineon. Why OktoberTech is such a big event for the company, and let's talk about some of the things along the robotics area, because you gave a really good talk this morning during the keynote, and you guys were making a lot of noise about not just robotics, but humanoid robotics. So in an event, I'll let you just do a quick overview of what you do here.
Okay, thanks very much, Mark. So this OktoberTech is really about bringing in collaboration, bringing the industry together so we can further understand and shape the trends of the industry. So whether that is in automotive, whether that's empowering AI, and of course now with the whole topics of robotics as well as humanoids moving forward. And here we've actually got a robot here, Acmea, and this is a great demonstration of how physical AI, how we're using AI in a physical way that can of course support the journey here that we are seeing. So for us, this market is growing heavily,
Yes.
right? And this is something that we in Infineon are very proud in supporting.
Well, that was kind of interesting. I was expecting to see some robotic technology here, but the tone, the flavor of the presentations is that while this is a technology demonstration, all the ingredients for the first time, probably in technology history, are now coming together, especially the AI piece. The AI piece is crucial to this, but the battery technology is getting properly efficient. The sensors are becoming efficient. The microcontrollers are becoming efficient. And I guess the question really is, because you meaning Infineon, was floating a big number in terms of what you think the market is, and you believe it's going to be a multi-robotic device per person at some point in the future.
Yeah, absolutely. So UBS actually put out some reports by 2050. This market could be greater than $5 trillion. Now, why is that? So take this humanoid itself. First of all, the compute, the brains, right? You need to make sure that you can do the AI edge technology, or you go into the cloud to actually do the intelligence, the compute side. Then you go from there, you can look at the microcontrollers to help support that inside. These could be functional safety microcontrollers or standard commercial microcontrollers as well. Then you talk about the battery. You're very right here, Mark. The battery lifetime is one of the key topics that we are seeing out there at the moment. And Infineon, for example, the joints of the humanoid, we're actually developing gallium nitride for motor controls. And by doing that, it can actually make the joints smaller. And at the same time, the density, of course, comes, but it also then we can improve the battery lifetime by using the most efficient technology. So these are the types of topics. And of course, communication is another area.
Right.
Security, making sure when a humanoid is working, it cannot be hacked as another example.
Now, what's interesting to me is when you look at usage models, because this was kind of a general purpose humanoid, and this form factor, really has a number of advantages in different areas. But in the hallways of Infineon, when you're kind of talking about, here's a market that will really explode. It's kind of like I was telling one of your associates before we did the interview. Sony had a robot dog years ago that they sent me one called the Ibo.
Yep.
And it was very primitive, 10-year-old technology, but it was incredibly popular. So I can't imagine what's going to happen. And those kind of robots back then didn't have AI with really, really bad battery life. But it was intriguing. We're talking about a new, different category of technology. So do you think that this is going to surface, first of all, maybe in robotic pets? Because it's not one size fits all. So any kind of musings on that?
Yeah, absolutely. In fact, we just held a focus group with about 150 executives talking about this very topic, about where do we believe the adoption is going to happen first. Mm-hmm. And of course, robotics is huge, and it depends upon the segmentation of the robotics areas. And what we are seeing at the moment is the robots will probably be adopted more in the industrial, the factory automation first.
Yes.
And it does not necessarily need to have legs. Maybe some of these
exactly
robots will also have wheels.
Right.
Because by using wheels, believe it or not, you can get maybe 6 hours of battery life, versus today, some of the robots with legs on certain functions may only last 2 or 3 hours.
Right.
So here within our own factory, within Infineon, we have a lights out factory that uses a lot of robots. Our engineers have chosen robots at the moment to be on wheels because battery life is so important within that mode of operation. So in this focus group I was just talking about, we just did a poll in the group about where's it going to adopt? Is it going to be consumer? Is it going to be industrial? Which are the areas? And a lot of people say factory automation is going to be the first adoption point for such robot/humanoids.
Right. You see, and what's interesting to me is that what's going to be, I'm going to kind of stretch your memory muscles here. The Lotus 1, 2, 3, or VisiCalc, the date both of us, that will really drive the category. Because if you recall, when the IBM PC came out, it was really Lotus 1, 2, 3. I got to buy an IBM PC to run this unbelievably productive program. And I'm wondering, in that context, do you see something like, for example, use me as an example. I hate cooking. My mother was a great Italian cook. I'm not a very good cook. Does a robot or something like that show up in the kitchen that, frankly, makes cooking a non-issue? So, and I'm sure I can't believe I'm the genius that brought that idea up. But I wonder if it's going to be some type of narrow usage model.
Yeah, look, the uses are going to be there, right?
Yeah.
So whether it's in the medical area,
Yes.
whether it's in factory automation, there's so many uses in hotels, for example, catering areas. Those topics will come through. But one of the key thing is we're actually, again, working with NVIDIA, with Jetson, where we're actually making sure that we support the compute topic, because without that compute, without the learning, is very difficult to of course learn and then deploy use cases for such robots. So this is where Infineon, we've of course collaborated with NVIDIA. We're doing the Jetson, and basically from there, these types of applications will be able to do learning models and then get better and better and better. So in your case, on the cooking, it may take a couple of learning iterations for it to then make the best ever Italian ragu that you've ever had in your life.
You said ragu, my mother would have a problem with ragu. But just to close out on this, the thing that's always been intriguing about Infineon, and I like to tell people, you're going to this event, what does this Infineon company do? And I said, well, but there's probably Infineon technology and at least one product inside your house. And you guys have always been in the thick of it. You have a portfolio of capabilities. I mean, you've got, what, 50 or 60 demos out here that are mind-blowing from an ingredient standpoint. But why does Infineon, from a DNA standpoint, what makes it such a compelling entity that it intends to win in many of the markets it plays in?
Yeah, first of all, I am very confident you have more than one Infineon product
Oh,
in
yeah.
your house, and especially in the cars as well. So look, Infineon, we pride ourselves on the area of innovation. We pride ourselves on the area of quality as well as manufacturing. And Infineon, the reason why we go through right spectrums of technologies, just take this humanoid, right away from the microcontrollers, whether it's automotive or consumer or industrial, whether it's in the areas of sensors, whether it's the radar sensors, whether it's the silicon microphone sensors, whether it's the cap sensors, right the way through to gallium nitride or silicon for the motor controls,
Yes.
whether it's BMS areas, whether it's security chips. All of these innovations, we really love putting our system experts together to create and enable such humanoids and robots that you are seeing here.
Well, and in a form factor like this, where you have multiple subsystems, they all have to work well together. They have to be coordinated.
Yeah.
And that's where Infineon shines.
Exactly. And this is such an exciting beginning of this journey. And we love working with our customers, the ecosystems of the industry, to improve ultimately our technology roadmap to support the use case.
So let's end it there. This is an exciting time to be in technology and in robotics. And Adam, I appreciate your time.
Thank you very much.
Thanks
Likewise,
again.
Mark.
Thank you,
All
Adam.
the very best.
Mark Vino with SmartTech Research.